And the sample proportion is X random variable over sample size. So today we want to rewrite this formula. Remember that p hat can also, which is the point estimate, can also be written as 1 minus p hat can also be written as 1 minus q. But do you know what q is? Q is sample failure. This is sample success, and this is sample failure. All right, so this one here remains sample failure. So actually, if you rewrite this formula, you have sample size that is needed for a specific margin of error E and level of significance 1 minus alpha is equal to p hat multiplied by q, q is failure, into the critical value alpha over 2 divided by margin of error, all squared. In other words, sample size will never be negative. The sample size will never be negative. That's why there's square there. Also, the sample size must be rounded up, must be an integer. Sample size must be rounded up and must be an integer. It cannot be negative. All right, so I just want to go ahead. I already explained that. We already know p hat is the sample proportion, and it is the same thing as the point estimate, while q hat is sample failure. Okay, and I can rewrite sample failure as 1 minus p hat. Okay, so Z alpha over 2 is critical value two-tailed. Critical value two-tailed, and we have studied how to calculate the critical value when it is two-tailed, divided by margin of error all squared. So we need to know this formula. And this formula is in the formula sheet anyway. So if you don't remember it, we have to give it to you. So you don't have to struggle with formula. And remember that our test number 4 will be on the 20th of November. Test number 4 will be 20th of November. And final exam will start on the 30th and finish on the 1st. As soon as you come back from Thanksgiving, final exam starts. Okay, so we're going to get an example. So we have talked about the formula. Whenever you're told to calculate the sample size to use in a population proportion, this is the formula you will use. Okay. Okay, so we're going to use this formula in calculating the sample size. Okay, so let's see. We remember that the P is point, we already talked about that. P is the point estimate, P hat. And anytime you do not know P hat, which is point estimate, you must assume that it is 0.5. And if P is 0.5, remember that P hat plus Q hat must be equal to 1. In other words, area under the normal curve is 1. So if P hat is 0.5, then Q hat must be 0.5 also, which gives the largest possible value. So what am I trying to say? Anytime you're told to calculate the sample proportion or the sample size enough to do a statistical test, maybe hypothesis testing or confidence interval, you must know how to calculate the sample size. So we already said that sample size is equal to P hat multiplied by Q hat into critical value two-tailed or divided by margin of error. all squared, that means that your calculated sample size cannot be negative, neither can it be decimal. You have to round up. Okay, so we're still talking about calculation of sample size. The sample size required to obtain this confidence interval, 1 minus alpha times confidence interval for P with the margin of error E is given by this. So that is the sample size formula we already talked about, rounded up to the next integer. And the reason why it says rounded up to the next integer is if you calculated 100.2 as sample size, you must round it up to the next integer. So it doesn't have to be up to 0.5. You have to round your sample size up to the next integer. And that is so that your answer here is going to be 101. Your answer here will be 101, where P hat is a prior estimate. So prior estimate is P hat. Suppose you are given that prior estimate is 0.5 or 0.3, then if prior estimate P hat is 0.3, remember it is probability, therefore it cannot be more than 1. So prior estimate is 0.3, then Q hat will be 1 minus. Area under the normal curve is 1, so 1 minus 0.3, which is the same as 0.7. If you're given the alpha, if you're told that alpha is 5%, so if alpha is 5%, you must divide alpha by 2. So that's what the formula says. For example, if I'm given this and I have, and I'm told that alpha is 5%, therefore the tail here is 2.5% or 0.025, and this is 0.025. And I'm told to use critical value for Z. So Z alpha over 2 is going to be Z 0.025. So you use your calculator to find the critical value. So let's find the critical value for 0.025. So let's go and find the critical value. I'm pulling my calculator up. So let's find the critical value for 0.025 using the Z. So second distribution. So I'm going to do second quit and get out of this second quit. And so second. All right, so I'm doing inverse norm, which is number 3, and finding area to the left, which is percentile, and that area to the left is 0.025, and the mean is 0, the standard deviation is 1. So remember that in normal distribution, you do not use degree of freedom. So I'm going to calculate, hit enter. All right, so my answer is negative 0.959, approximately negative 1.96. Okay, so now I can calculate the sample size. And by the way, I can store this in my X. So I'm going to store this in my X. So if I store this answer in my X, so I don't truncate it, and I can square this answer also immediately. So I go to square this answer, squared. All right. So I'm going to square this answer, and I have it squared, and I'm going to store it in X. All right, so now I suppose I'm given that p hat is unknown. If p hat is unknown, then the sample size is going to be 0.5 multiplied by 0.5, which is both p and q are the same, multiplied by the quantity I have in my x. So I am going, and 0.5 multiplied 0.5 is 0.25. So I'm going to go back to my calculator, and I'm going to multiply that, my answer, by 0.25. So multiplied by 0.25, and I'll get an answer. And that answer is approximately 0.996. But guess what? I have to round it up to 1. So that is a sample size. Sample size is approximately 1 because sample size cannot be decimal. Sample size is not allowed to be decimal. And by the way, there is something we haven't done. So I'm just going to go back and pull my x. What if I'm given that the margin of error is, if the margin of error is 0.3, so I'm going to divide the margin, divide x by margin of error. So divide x by margin of error, and I have this number, and then multiply by 0.25, because you must divide your critical value by margin of error. So let's go back. So we have second verse, we select number 3, and then we have all we have to do, and we got it, and divide this answer by margin of error 0.3, and we have an answer. And then we square this, we square it, so when we square this, we have and then I'm going to store it in x. Alternatively, I'll multiply immediately by 0.25. So I'm going to pull that down again, enter, second enter, second enter. So I have the critical value, second distribution, and inverse norm. So I calculated inverse norm, and I divide inverse norm by 0.3, which is the margin of error. Divide inverse norm by 0.3, which is margin of error. And I have to square this. So when I square it, I get critical value divided by margin of error. And then I can multiply this by 0.25. That is success multiplied by failure, 0.25. And I'll get an answer. And this answer is approximately 10.67, which is 11. Because in sample size calculation, you must multiply, must round up. So the rounded up answer is sample size is equal to 11. So the sample size needed for this calculation is 11, whatever it is, maybe grams or anyway. So that's one calculation. Whenever we are told to calculate the sample size, we have to make sure we know p hat. If we do not know p hat, if we don't know p hat, we shall assume that p hat is equal to q hat. So if p hat is equal to q hat, then both of them are 0.5. And so we go with that. So let's see another example. So we're talking about calculation of sample size with calculation of sample size using the population proportion. So let's go to calculation of sample size. And if a prior estimate of P is unavailable, that's why we are using this, because 0.5 times 0.5. So suppose we don't know the prior estimate of the P hat, then 0.5 multiplied 0.5 is 0.25. So we use 0.25 to calculate the sample size. And then make sure we use the margin of error given to us. All right, so let's get an example. A sociologist wanted to determine the percentage of residents of America that only speak English at home. What size sample, or what size of sample should be obtained if she wishes her estimate to be within 3% and point with 90% confidence interval, assuming she uses the estimate obtained from the census. Okay, and that estimate is 82.4%. Okay, so let's list what we are given. So we are given the confidence interval. So the confidence interval is 9% up 0.9, which is 90%. And if confidence interval is 90%, alpha is equal to area under the normal curve minus 90%. Therefore, alpha is 0.1. Okay, so if alpha is 0.1, then we divide alpha by 2. So alpha over 2, which is the critical value on the left, is 0.05. Now I will have to calculate the right tail and left tail critical value. So the right tail and left tail critical value. Don't forget that the normal curve is symmetrical. So Z alpha over 2, or Z.05. And here, this is Z.05 also. Don't forget that the left must be negative. Okay, so I will get my calculator. And by the way, what else am I given? So let's see. With size of sample should be within the estimate of 3 percentage points. So I'm just going to use this like this. The point is, so the margin of error given to me is 3. So I am going to calculate, but before I calculate, I need to write the formula. So the formula will be N is equal to, I am given success to be 82.4. So 82.4 is the same as 0.824 multiplied by 1 minus 0.824. Then multiplied by the critical value, and that critical value is Z alpha over 2.Z.05 over margin of error, which is 3 points, all squared. So I have written the formula I need. So now I need to calculate. So I'll get my calculator, put the data in. The best thing to do is start from the square. So inside the square, I have the critical value of 0.05. So how do I calculate critical value? So I go to second. I just go to second verse, and the critical value for Z is number 3. All right, the critical value for Z is number 3. and the area to the left is 0.05, and the mean of a normal distribution is 0, standard deviation is 1. So I now have to calculate. So I'm going to calculate. So if I calculate this, I have the critical value of that. Then I divide by 3 percentage points, divide by 3, I get an answer. Then I will square this, I get an answer. Then I can store my answer in Y1, or I can go ahead and multiply out. I have already squared it, so I'm going to multiply by P and multiply it by Q. So multiplying by P, I have 0.824, and multiply again by 1 minus 0.824. 1 minus 0.824, 0.824, and then I'll get an answer. Okay, so this is my answer. Remember, I have to square this, so my answer is not allowed to be negative, so I want to make sure. So what we're going to do is we're going to go back and recalculate and so that we'll make sure we square that. So go back, second verse, go to inverse norm, which is number 3. The area to the left, and then you square that, you enter, okay, and then divide by the margin of error. So I'm going to divide this by margin of error, divided by margin of error, which is 3. I hit enter, and after dividing my margin of error, I square my answer. So I square this answer, and then that's what I have. Then multiply by my P hat and my Q hat. So I'm going to multiply by Q hat and P hat. Multiply by 0.824824, and multiply again by 1 minus 0.824. Well, you know what? I can just leave my answer like that first. So I'm just going to delete this and delete that and delete that. And then I hit enter. And then I'm going to multiply again. Multiply again by 1 minus 0.824. And before I multiply, I really want to use parentheses. That way my calculator will not mislead or misunderstand my. So 1 minus 0.824. And whenever you finish calculation and your answer is negative, something is wrong, because sample size is not allowed to be negative. So we can accept the fact that the sample size is 1, but we cannot accept the fact that sample size is negative. Okay, so let's go to the next one. Okay, so we have the critical value for points. Okay, so the margin of error is actually 0.03 because it said it's percentage point. Okay, we needed to convert that to. So let's go ahead. It says 3 percentage points. So it was 3 percentage points. So this is the formula here, and then we have to calculate that and make sure. So recalculate, and find the sample size, remember you have to start calculating from the parentheses. So the critical value for z equal to 0.025 or 0.05 is 1.645. So you can just do 1.645 divided. You are dividing because the margin of error is in the denominator, 0.03, and then you get an answer, and then you square your answer. Okay, and then when you get this answer, you multiply your answer by your P and multiply again by Q. So multiply your answer by P hat. So P hat is 0.824824. And I'm just going to put my answer first. And then multiply again by 1 minus 0.824. Multiply, use parentheses, 1 minus 0.824. And close parentheses, get an answer. Okay, so the actual sample size will be approximately 436.04. But guess what? Even though the decimal is 0.04, you have to round up. Your answer is not allowed to be decimal. You must round up in the calculation of sample size. You must round up whenever you're calculating sample size. So I hope you are not going to say, okay, 0.04 is too small, we throw it away. No, you're not going to throw it away. You have to round it up. In sample size calculation, you must round up. The rule of rounding is disobeyed. We round this value up to 437. The sociologist must survey 437 randomly selected Americans. So the sociologist should use the sample size of 437 Americans. So you have answered the question right now. So this is about calculation of sample size for proportion. So let's go and find a calculation of sample size for sample mean. This is sample proportion. So let's go to 9.2. Let's see if it's 9.2. Okay, let's go to 9.3 and find the calculation of sample size for population mean. So let's do that. Calculation of sample size for population mean. All right, so let's see what is here. Let's move to, okay, so we are looking for calculation of sample size for population mean. The calculation is, the formula is different, so we want to make sure we know the formula. The formula for calculation of sample size for sample mean is different from calculation of sample size for sample proportion. So we have to be careful and read the question very well and know when the question says calculation of sample size for population mean. Okay, so in this question it says calculate the sample size. Okay, well, so the question is saying determining the sample size n again. So remember, the question for sample size can be from population proportion or population mean. So you have to be careful because there are two different formulas and you don't really want to mistake the formula. You will have the formula in the formula sheet, but do you really know which one to use? Do you know when the question is about calculate the sample size from population mean, and when the question is calculate the sample size from population proportion. You have to be careful. You need to know that. So when you're given a question, you read it very well. Also, you will always be given the confidence interval. But one thing you want to remember is that confidence interval plus the critical value or alpha is equal to area under the normal curve. So when you are given the confidence interval, all you have to do is 1 minus confidence interval to get the alpha. And another thing you need to do is every confidence interval in calculation of sample size must be divided by 2. So I mean every alpha. So you divide alpha by 2. When you divide alpha by 2, then you have two tails. You find the area to the left. Remember, if you find the area to the left, you already know area to the right because normal curve is symmetrical. Okay, so let's get a question. All right, let's get a question. Determine the sample size for this time. We are determining the sample size for population mean. Okay. Oh yeah. How large a sample will be required to estimate the population mean weight of pennies or penny manufactured after 1982 within 0.005 grams with 99% confidence? So this time we are given 99% confidence. And since we are given 99% confidence, we want to find out what alpha is. So 0.99 confidence interval plus alpha is equal to 1, area under the normal curve. Therefore, alpha is 1 minus 0.99, and 1 minus 0.99 is 0.01, so alpha is 0.01. Okay, and in every confidence in every sample size calculation, alpha must be divided by 2. So alpha over 2 is 0.01 divided by 2, and that is 0.005. In other words, this time I am going to calculate the critical values. And by the way, let's go back, let's write the formula again. So we'll look at the formula again. So this is the formula. It is critical value multiplied by standard deviation divided by margin of error. You see how this one is different. In calculation of sample size for proportion, there was no standard deviation. And also note that the standard deviation used here is the standard deviation of the sample. In other words, for us to calculate the sample size, we do not know the population sample size. We do not know, and we assume we don't know it because if we do know it, why? I mean, it is, we are calculating the sample size for, for a small sample. All right, so we go back to that question and let's try to answer the question. So let's answer this question using the correct formula. Using the correct formula, let's answer the question. So calculation of sample size from the sample size for the population mean, okay, is equal to parentheses. In the other one, we had PQ, but here we just have critical value divided by 2 multiplied by standard deviation given to you all over margin of error, all squared. So for calculation of sample size for population population mean, it is critical value multiplied by standard deviation all over margin of error. So you will now do the substitution. So find out what you are given. We already know that the area to the left is 0.005. So we do the calculation. So I'm going to substitute in the formula. So I have sample size is equal to 0.005 multiplied by standard deviation, and the standard deviation, let's see, and the standard deviation is 0.02, 0.02. So let me take some of this away. So standard deviation is 0.02 divided by the margin of error. And what is the margin of error? Okay, so whenever I see within, I know it's margin of error. So that is 0.005. Remember that you have to square it because your answer cannot be negative. Your answer cannot be negative and your answer cannot contain decimal. So let's go ahead and calculate. So you find the critical value, multiply by the standard deviation, divide by margin of error, then square all of them. All right, so let's do that. So we pull our calculator up. So let's pull our calculator up. We'll find the critical value, and remember it is Z critical value. So second distribution, number 3 as Z critical value. Okay, so that is 0.005. Okay, arrow down. The mean is 0, standard deviation is 1, and I'm going to paste. Then multiply this answer by 0.02. Then divide this answer by 0.005. 0.005. Then square the result. Square the result. So I'm going to square. So the answer that I have, let me see. Let's see. All right, let's see. Did I square? I'll go back. So second distribution, and I have number 3, and I will calculate. And then I will multiply my answer by 0.002. Okay, 0.02, and I hit enter, and I will divide this answer by 0.005. I hit enter.